Okay, we're going to look now at the chain rule of differentiation. I'll show you the sort of function that we're going to be finding this particular rule useful for. If we've got y equals, let's say, 2x plus 1 to the power of 2. Let's say we want to find that. We want to find dy dx for that. Find dy dx. Well, we could expand that out, couldn't we? I mean, that's what we do. We'd say, okay, therefore y equals, we'd expand, we'd go, well, that's 4x squared plus 4x plus 1, and then we go, righto, well, that's simple enough. Now I've got it like this, I can derive it as 8x plus 4. However, if I should change this to power 20, this is, we're now in trouble, aren't we? We don't have a technique for this. Certainly not going to expand it. It's a big expansion. So we wouldn't be doing that. We'd be looking for something else. And thankfully there's a rule, the chain rule is going to help us through this scenario. So we'll come back and do that in a sec. So the chain rule does this. If I've got y equals some kind of function of x in here to the power of n, okay, so this is what I've presented with, some sort of function in here to the power of n, then dy dx will equal, right, this n comes down the front, no change to my function of x, and I change that to n minus 1. Now this is looking very familiar, isn't it? Bring the n down, hold that as, and then reduce that by 1. But the chain rule addition to this, because this is now a function of x, it's not just x. So what we do is we multiply by the derivative of that function. Okay, so let's see, that's the chain rule there. Let's see this applied now to this question. So let's now using chain rule on that. Using the chain rule for this function here, we would go dy dx equals, I'd bring the 2 down the front, 2x plus 1, what do I do to this? I drop that by 1, and I multiply by the derivative of what's inside. Let's not forget to do that, times 2. I can then multiply this 2 by this 2 to get 4. 4 by 2x plus 1 to the power of 1, it's just 4 by 2x plus 1. And look at what we got there, 8x plus 4. Right, same result as we got there by expanding, so that when we've got this horrible 2x plus 1 to the power of 20, it's not going to take us any longer to derive it, because we're just going to take the 20 down, 2x plus 1 goes to the 19, multiply by 2, last step is just to multiply the 20 by the 2, just to simplify that, 40 by 2x plus 1 to the 19, and we have got our derivative of 2x plus 1 to the power of 20. Okay, let's have a look at a couple of other examples. Let's look at differentiating or finding dy dx for y equals 4x cubed minus 5x. Let's put that to a negative power, minus 2. Alright, so let's get dy dx for this, or y dash. Bring the minus 2 down. 4x cubed minus 5x stays there. We subtract that power by 1 to minus 3. Now we multiply by, what's the derivative here? 12x squared minus 5. Okay, and bracket that, because that needs to be all together. Now we just bring the minus 2, multiply it by that. Minus 24x squared plus 10, all by 4x cubed minus 5x to the minus 3. Right, that could be rewritten. I could leave it like that at a pinch, but we could write it as 10 minus 24x squared here, and this negative power becomes positive power 3 down here in the denominator of that fraction. Okay, we'll leave it at that. I think we can do some questions now out of exercise 22b. In fact, I think I wrote the questions at the top here. Yes, I did. Questions 1, 3 and 4. That'll be for our next lesson. Okay, cheers.